Oh, nobody here already at least. That's, oh, yep, there. I should hide this, make sure it doesn't show up. 2 people entered. All right. Yeah, I'll just keep reading. I'm sorry, baby.
You don't feel sick?
No, I feel okay. All righty, Alma, Holly, and Robert. I think Robert and Alma were first. Robert, what can I do for you?
Yes, sir. I was wanting to see if you could go over a couple questions on the study guide.
Yeah, we can talk through some study guide stuff. What would you like to look at?
Number 6. It's a piecewise.
This guy?
graph.
Okay. So because it's a study guide question, I don't want to go through the whole thing, but really the trick here is going to be to draw the graph.
Okay.
So let me see what we can do here. All right, so here's our function. Now the trick, are you comfy with how you draw the graph of something like this?
Yeah, I'm a little. I can probably grind it through, but I'm not as confident as I like to be.
All right, yeah, so let's work on that a little bit. We want to graph g of x equals this complicated ass piecewise thing. It's x if x is less than 1. It's 4 if x is exactly equal to 1. It's 2 minus x squared if x is 1 is less than x is less than 2. And it's x minus 2. Oh, sorry.
There's another 5. It's just
X is greater than 2. All right. So if what I would do to graph this, if you're not super comfy with graphing these, first thing I would do is graph each one of these functions on their own. That's what I'm going to start with. I'm going to start with the graph y equals x, the graph y equals 4, the graph y equals 2 minus x squared, and the graph y equals x minus 2. Because the way we get the graph of this function is kind of by stitching the graphs of all these guys together.
Yeah.
And I'm just going to do real simple sketches down here. So y equals x, is a line with slope 1 going through the origin. Y equals 4, we know is a constant function. So just a horizontal line, y equals 4 like this. 2 minus x squared is the parabola x squared flipped upside down and bumped up 2 notches like that. And he looks like this. And then x minus 2, this is a line with slope 1, y-intercept -2. So he looks like this. I should probably let him continue over here a little bit. So these are the 4 graphs that I'm going to have to stitch together to make the graph of g of x. This thing says g of x acts like x, but only to the left of -1. So if I mark this as -1, then the part of this graph that I want to hold on to, I'll kind of put in bold here, is really just this part. And this guy says to the left of 1. Yeah, sorry, all the way over here to 1. So this whole thing. Yeah, okay. And then right at x equals 1, it behaves like the constant function 4. That's just 1 point. And then for x's between 1 and 2, so if I mark this as 1 here and this as 2 here, for x's between 1 and 2, my function behaves like this. And then everywhere to the right of 2, it behaves like this thing, which is this part here. This is 2, this is 1. All right, so I'm going to take the bold parts of these graphs and kind of glue them together into the graph of f of x. That's how we get these piecewise functions. So I'll give myself some space. All right,
Now, okay, so how many questions are on the test? 14?
14 altogether, yep.
14? Okay. How many free response ones are there?
6.
6. Cool.
So this is 1. This is 2. This is -1. And then the heights here are going to have to go up to like 4 at least. So let me mark these a little smaller. 1, 2, 3, 4. Okay. Everywhere to the left of 1, we're going to act like this guy. So that would be 1, 1. And everywhere to the left of that, we act like him. So here's the y equals x piece. And then right at 1, g of x is equal to 4. So right here we'll have this. G of 1 is 4. And then everywhere to the right of, or everywhere between 1 and 2, sorry, we're acting like this 2 minus x squared. So if I plug 1 in here, I get 2 minus 1 squared, or 1. So this is actually going to come, we're going to be looking at, it's this part which connects up like right here. And at 2, we'll have 2 minus 2 squared. That's 2 minus 4 is -2. So let me come down here, -1. 2. This curvy bit here. That is a part of that parabola. That's this part of that parabola. And then we jump
Okay,
back
so
up
doesn't that start at 2?
Yes, but because of the way the piecewise function is defined, we're not going to, I only want, so it's true that the vertex is up here at 0, 2.
Yes.
But my function only behaves like this for x's between 1 and 2. So
Gotcha.
I could bring this all the way up over here, but that part of this graph isn't on this graph.
Gotcha.
Does that make sense?
Yep.
So this is the graph of our function here. And once we have this, we can figure out all the limits and all the little things that we need. So I'd say this is the challenge, is getting comfortable graphing these piecewise things.
Yeah. I'm going to go back and do a couple of them, but I just wanted
It's a good idea, yeah. And there's a few more like this. There's one like this back in the earlier homeworks, when we had that homework on the limit of a function, section 2.2, before the limit laws. And if you look in the textbook at section 2.2, you'll find 1 or 2 more problems like this that you could use to practice. But now that we have this graph, let's take a look at some of the limits they're asking for. So the limit as x goes to 1 from the left. What is that?
1.
Yeah, it's 1, right? If I'm walking along this graph, and I sneak up on 1 from the left, I'm going towards this height here, which is 1. And the limit as x goes to 1 from the right.
1.
Also 1. What about g of 1 itself, part 3? So I would think like,
Oh, so it would be 4.
yeah, so g of 1 itself is all the way up there at 4.
Yeah.
So the limit from the left and the limit from the right, I can say lim x to 1 minus g of x. This is equal to 1. And lim x to 1 plus g of x, this is also equal to 1. And so from that, we could say that the limit, the overall limit, lim as x goes to 1 of g of x does exist and is equal to 1. But g of 1 itself is equal to 4. So we would say, for example, if we were asking about continuity here, that this function is discontinuous at 1, because even though the limit exists, it's not equal to the function value there.
Yeah.
Right, and then there's a few other questions. I won't spoil the ones at 2 here. I'll let you work these out, but go back and see if you can draw this graph yourself. Start by taking each one of these, or if you want to, I think I have some resources on graphing piecewise functions in the, in the modules. Let me see this. I guess you probably won't communicate the one college algebra question that's there to anybody in college algebra right now. Make sure I have something here on piecewise. Yeah, so you might look at this link here on piecewise functions, or this guy on piecewise functions, any of these, if you want a little bit more help with those, because that is something you want to get comfy with for the purposes of the test.
Okay.
All right, I'm going to start cycling through, but then I'll come back to you after we get through everybody else, all right?
I'm gonna head out. That was the only real question I had right now.
Oh, all right, well, I'll be here until 2.
Appreciate it.
Of course. I think Alma was next. Alma, what's shaking? Alma, are you there? Okay, yeah, sure. I got you. Oh, sorry. So, number 4 on the study guide. Is this still the study guide? It is, right? So this one, is this the one we want to see? All right. The trick here is just to handle the algebra carefully. We've got to follow that order of operations, and we got to make sure we don't kind of step on our own toes. So we've got lim h to 0. And then upstairs, 5 plus h to the negative first power minus 5 to the negative first power all over h. So the trick to remember here is that anything to the negative first power is 1 over that thing. So like 5 plus h parentheses to the negative first power is 1 over 5 plus h. And 5 to the negative first power is 1 over 5. That's what we need to get started. This is sort of the rule, and this is how it applies to the 2 pieces we have here. So we have lim h to 0, 1 over 5 plus h minus 1 over 5, and all that is being divided by h, just like this. Now, if I want to clean this up, the challenge with this problem is that if you just send h to 0, if you just plug in 0 for h, the top goes to 0 and the bottom is also 0. And I can't divide anything by 0. That's an issue. So I really want to get rid of this h down here. The only way I can hope to do that is by cleaning up the algebra in the top. Right now, the top has 2 fractions being subtracted from each other. So if I want to clean that up, I need to have a common denominator and put them together. So this is going to be 1 over 5 plus h times his denominator is missing the 5. This guy has a factor of 5. This guy has a factor of 5 plus h. So to get this guy the factor of 5 that he's missing, I'm going to multiply by 5 over 5. And then I've got minus 1/5. To get this guy the factor of 5 plus h that he's missing, I'm going to multiply by 5 plus h over 5 plus h. And then everything still being divided by h. And we have to remember that the tops and bottoms of all fractions are always thought of as being in parentheses. So it's really like this. And I would suggest writing it like that. Now what you see is when we multiply these fractions here and here, their denominators will be the same. This is lim h to 0. Here 1 times 5 is 5. And downstairs I'll have 5 times 5 plus h minus 1 times 5 plus h is 5 plus h. And downstairs I have 5 times 5 plus h. And all this is still over h. Now this and this have the same denominator, the two little fractions in the top. So I can subtract them. That's what we needed to do to subtract them. So I get lim h to 0. My fraction in the top is going to have denominator 5 times 5 plus h, and upstairs I'll have 5 minus parentheses 5 plus h, and then my big fraction downstairs still just has h in the bottom. Now I distribute this negative. And I'll get limit h to 0, 5 minus 5 minus h over 5 times 5 plus h, all divided by h. 5 minus 5 is 0. So this top is really just negative h. Downstairs I have 5 times 5 plus h still. And instead of writing this as a giant fraction divided by h, I'm just going to write this divide by h as a multiply by 1 over h, because that's what it is, right? Dividing by h is the same as multiplying by the reciprocal. If you can think of this as h over 1 to help you see that we're really dividing by or multiplying by 1 over h. And the magic is that now these h's can cancel. So as h goes to 0, this is going to be, this is going to be lim h to 0. When you cancel from the top, you'll have negative 1. And then downstairs, we still have 5 times 5 plus h. So this is negative 1 over 5 times 5 plus 0. 5 plus 0 is 5, so this is negative 1 over 25. Okay. Questions on this one, Alma? You feeling comfy with what we did here?
Professor, sorry?
That's okay. I was talking to a different student. So I do have to go in order here. I think after Alma was either Holly or Mackenzie. I'm really not sure. So whomever wants to ask their question, go ahead, and we'll move to the other next. Holly, okay. Number 10 on the study guide. Holly, remind me, are you in Calc 1 or Calc 2? All right, here we go. Yeah, this is a cool one. All right. So they're telling us that this limit is the derivative of something, right? So what we have to do is compare this limit to the definition of the derivative. Okay, the limit definition of the derivative, remember. So I don't know if you guys asked for definitions in class today, and this one was one that we've used so much, it didn't even occur to me I need to remind you of it, but the limit definition of the derivative, f prime of x, is equal to the limit as h goes to 0, f of x plus h minus f of x all over h. Now we want to know what derivative is represented lim h to 0 cosine of pi plus h plus 1 over h. And what I would do here is try to see this thing in context of the thing above. The first thing I see here is a cosine, right? So I'm thinking the function f is probably cosine. So I would say, well, if f of x is cos x, then f primed of x, let's just write down what that limit would look like and compare it to what we have above, is lim h to 0 cosine of x plus h minus cosine of x all over h. And now I look at this, I look at this, and I ask, what is different about this and this? So can you help me out a little bit from here, Holly? What are we thinking? Is there a way to connect these two sort of things? Is there a particular number I could plug in for x here to make this look like this? Look at the first cosine. So that's all right. So the first term right here, if we just pay attention to this, cos of x plus h here, and cos of pi plus h here. Yeah, pi. So f primed of pi here would be lim h to 0 cos of pi plus h minus cos of pi all over h. And the cosine of pi is -1, so this is lim h to 0 cos of pi plus h minus -1 over h, which is lim h to 0 cos of pi plus h plus 1 all over h. So what we see is that the limit we started with, the limit they gave us right here, is the definition of the derivative for the cosine function with pi plugged in. So this piece is the derivative of f of x equals cos x at a equals pi. So first kind of clue was the cosine here. The cosine here said, okay, well, let's just see what the limit definition of the derivative is if you plug in cosine of x for f of x. That gave us this. And then the next sort of clue was comparing the numerators here and here. Specifically the first term of the numerator, this piece, cos of x plus h, with this piece, cos of pi plus h. The only way for this piece to be the same as this piece is if we swap pi in for x. So that's what we do. We say, okay, if I swap in pi for x, then f primed of pi would be cos of pi plus h minus cos of pi all over h. Now the cos of pi, we know that that's -1. So this is minus -1. And we say, oh shit, look at that. That really does turn into the limit they gave me. This is the same as this. So the limit they gave me must be the derivative of cos x with pi plugged in. So this is the derivative of cos x with pi plugged in. Cool. cool. Yeah, these are fun problems. They tend to be a little bit hard conceptually. If you want to look for more practice, look in the textbook in section. It's probably, let's see, probably over here. The rest of these. Here. Definition of derivative from the tangent line. These are all good problems, but there's the ones that ask you to think critically like this. Here you go. Look at numbers 37, 38, 39, 40, 41, and 42. 41 is the one we did, but 37 through 42 in section 2.7. So section 2.7, numbers 37, 38, 39, 40, 41, and 42 would be good places to kind of look at more of these and get comfy with them. And some of these will have, the odd ones will have answers in the back of the book. All right, I'm gonna keep cycling around. I think Mackenzie, you're up.
I was just like, I'm struggling finding like if an equation is differentiable or not.
Yeah, that's a tricky thing. From the graph, the idea is it's differentiable at an x value if the graph isn't like pointy, if it's nice and smooth. So you have to be continuous and you also have to be smooth. What would you, is there a particular one that you're looking at?
No, not particular. I was just like, I understood from a graph. I was just wondering if we had to find one from an equation.
Well, yeah, I mean, I certainly could ask you like, is this function differentiable at this number? I could ask like, is f of x equal to x squared if x is less than or equal to 0, and 4x if x is greater than 0, differentiable at x equals 0. This sort of thing would be a fair question, and you would have a few ways to attack this. But my advice here would be first to sketch the graph. That way you'll at least have some idea. So, to the left of 0, this thing behaves like x squared, which looks like this. And to the right of 0, this thing behaves like the function 4x, which looks like this. So the question is kind of, do these join up in a smooth way here, or is there a hard corner? And it kind of looks like there might be a hard corner there. But if we want to know for sure, then we need to use the definition. So remember, a function is differentiable if and only if the limit defining the derivative at that point exists. So f primed of 0 would be the limit as h goes to 0, f of 0 plus h minus f of 0 all over h. This is just like that last problem we were doing, kind of.
Mm-hmm.
But then you have to look at the left and right limits separately, because we want to know, does this exist? So we look at the lim as h goes to 0 from the left, f of 0 plus h minus f of 0 over h, and we'll look at that separately from the lim as h goes to 0 from the right. So 0 plus h is the same as h, so this is lim h to 0 from the left, f of h minus f of 0 over h. F of 0 is 0. If you plug 0 into this function, since 0 is less than or equal to 0, f of 0 would be 0 squared, which is 0. And since h is going to 0 from the left, h is a little smaller than 0. It's not bigger than 0. It's not here. This would be bigger than 0. It's smaller than 0. It's here. So this limit is lim h to 0 from the left, h squared minus 0 over h, right? This piece would be h squared because h is to the left of 0. This piece is 0 because f of 0 is 0. And the h downstairs is just the h downstairs. So that comes out to lim h to 0, h squared over h, which you can cancel in h, is lim h to 0 of h, which is 0. And that makes sense with our graph, right? If we think about the tangent lines coming in here, it looks like the tangent lines are getting shallower and shallower, and maybe right as we get very close to 0 from the left, the tangent line is like horizontal. So the limit defining the definition of the derivative when we look from the left looks like it's 0. If we look at the other one, lim h to 0 plus f of 0 plus h minus f of 0 all over h. This is lim h to 0 plus f of h minus f of 0 over h. F of 0 is still 0, but f of h now, because I'm going to 0 from the right, if h is going to 0 from the right, then I'm considering h's which are a little bit bigger than 0, which means f of h is going to be defined according to the second rule, right? F of x is equal to 4x if x is bigger than 0. So if h is a little bit bigger than 0, then f of h is 4h. So this is 4h minus 0 over h, instead of h squared minus 0 over h. Cleaning that up, that's just lim h to 0 plus 4h over h. You can cancel the h's and you get lim h to 0 plus of the constant function 4, which is 4. So does this limit exist?
No,
Why not? You're correct. Good. Why not?
because one goes to 0 and one goes to 4.
Good. The left limit is 0. The right limit is 4. So the overall limit defining f primed at 0 does not exist. So is this function differentiable at 0?
No.
No. Good. Because f primed of 0 does not exist by definition. The limit defining f primed of 0 dne, because the left and right limits don't match. The way we should think of this, Mackenzie, is as we get very close to 0 on the left-hand side here, my tangent lines kind of look like this, right? And as I bring this in, so if my point of tangency is like just a tiny micrometer to the left of 0 there, as I bring the point of tangency closer and closer to 0 from the left, these tangent lines are going towards being horizontal. But anywhere over here I look at a tangent line, the tangent line looks like this. So there's no smooth transition, right? At this point, there's like a jagged transition. And that jagged transition is the geometric or visual interpretation of failing to be differentiable. But the way we need to check it every time, if we're asked like check if this is differentiable, you got to check whether the limit defining the derivative at that point exists or not. And that means looking at left and right limits separately. It can be a little tedious, but this is the procedure.
Okay, thank you.
You're welcome, of course. I think that brings us to Alexander and then to Cody. So Alexander, you've been waiting patiently. What can I do for you, buddy?
I was going to ask you about 11 on the Cup 2 homework, but then I was finally able to get it during, like, while you're helping everyone else. That problem was ass. That problem was so bad.
Let me take a quick peek here and we can see if there's anything you want to talk about on it. You're talking about from homework 5 here?
Yeah.
Number 11. Let me remind myself what that was. I actually forget. Oh yeah, this is horrible. So you completed the square and then
Yeah.
you do the trig sub and then it's secant cubed and then you do the looping.
Not
like-
even trig sub first. First,
Go
you have to
back.
sub, before you can even get to trig sub, you have to sub for like minus x plus 5. This would be like what, x plus 7?
You can, you don't need to do the little u sub. So I can show you a slightly faster way to do this. Would you like to see that?
I guess so, but I mean, the main issue for me was trying to do integral of secant cubed at the end with the coefficient. That was where I got hung up.
Yeah, the secant cubed is hard. My advice, my honest advice, anytime the secant cubed integral shows up in the context of another problem, look up the secant cubed integral and plug it in. It's an integral that shows up often enough that it's worth committing to memory. So secant cubed on its own, secant cubed theta d theta, this is 1/2 secant theta tangent theta plus the natural log of secant theta plus tangent theta plus c. It's people ask me a lot, should I memorize this integral or not? And usually what I say is, if I were to give you this problem on a test, like on its own, just integrate secant cubed, then I don't want to see you just regurgitate this on the page. But this integral does show up often enough, like in the setting of trig sub and stuff, that I think it's worth knowing. If you've got a little extra space in your brain, if you're feeling not super overwhelmed by the things that you need to remember already, it might be worth adding this here. Not because I'm going to give you a problem on a test where you need secant cubed in the context of something else, but because out there in real life, as you're solving mathematics problems, you'll be surprised how often secant cubed comes up. And then when we attack this guy, whatever, x squared plus, was it 49x or 14x or 28x or something like that?
7x.
So this
Minus 5, minus 10x, but yours was 7, I think.
Here, we'll do it like this then. So x squared plus 10x dx. First, we complete the square. And completing the square under there is going to look like x squared plus 10x plus 25 minus 25 dx, which is going to be square root of, these first three are x plus 5 quantity squared, and then minus 25 dx. Now from here, if you want to save yourself a little time, instead of doing a separate u sub, just let x plus 5 be equal to, what do we need here? This is going to be x plus 5. Oh, this might not be so bad. Okay. So I was thinking we were going to have a plus here, which means a tangent sub, which means secant cubed. But this might not come down to a secant cubed. I don't know, it's going to be something else. So the substitution here is x plus 5 equals 5 secant theta. Was it a plus or a minus here? Let me make sure. Yeah, no, this is not going to be as horrible. And now if you take differentials on the left and the right, you can still just differentiate this. On the left, because the 5 differentiates to 0, you will just get dx. Right? Technically, it's like 1 plus 0 dx equals 5 secant theta tangent theta d theta. We may still end up with a looping integral here, but we'll see. This means that secant theta is x plus 5 over 5, and we can interpret that as a hypotenuse over an adjacent. So my triangle is going to look like x plus 5 here, and the adjacent side is 5. And then the square root down here is this squared plus this squared equals this squared. So this squared equals this squared minus this squared. So this guy is the square root of x plus 5 squared minus 25. And that'll let us get into the trig sub a little faster. And then my integral would become, I'll do it over here. If x plus 5 is 5 secant theta, then x plus 5 squared is 5 secant theta squared. Then we've got the minus 25. Yeah, these can be a little bit worse. And then here we'll have 5 secant theta tangent theta. D theta. And then the trig
And that
sub in here.
becomes, that'll end up with a secant cubed in there, yeah?
I'm less certain now than I thought at start. If this was going to be a tangent sub, then we would definitely end up with a secant cubed. But I think we're going to get something else with this one.
Because we have secant tan squared.
Oh, is that where this is going to land? So this will be secant squared. This is going to be square root of 10. Yeah, it's going to be a looping thing. It'll be, you can turn it into a secant cubed thing, yeah. So that's 25 secant squared theta minus 1, which is indeed tan squared. So yeah, this is going to be a, you'll have a tangent here and then a secant here and a tangent there. So yeah, it is. This is nasty. This is a looping integral. There's no nice way about it. This is 25 times tan squared theta. So that's going to be 5 tan theta times 5 secant theta tangent theta d theta. So you're right. There's no escaping it. It's a 25 integral secant theta tan squared theta. And one of the ways to attack the secant tan squared integral is to rewrite it in terms of the secant cubed. Yeah. So this will be 25 tan squared is the same as secant squared minus 1. So I can write this as 25 times the integral of secant cubed theta d theta minus 25 integral of secant theta.
Are we going to learn about ways to attack this with hyperbolic trig functions or no?
To attack this with what?
Hyperbolic trig functions?
I'm not aware of a nice way to attack this particular one with hyperbolic trig functions. There are some things like this that we can handle with hyperbolic trig functions. Well, maybe this could be. Yeah, I think you probably could do this with like a hyperbolic secant substitution instead. Let me look back here.
I just wanted to think about hyperbolic trig. I just saw it on Wolfram Alpha that was also an option. I just don't know anything about it.
So the hyperbolic, here we go. So these are the ones that naturally work out with hyperbolic trig substitutions. The inverse hyperbolic sine function can be cooked up as this integral, which naturally would be a tangent substitution. If we wanted to make, so you need to know what the hyperbolic trig identities are, because just like it's the Pythagorean identities for the regular trig functions that make things go, we need to know the corresponding identities for the hyperbolic trig functions. And if I'm honest, I don't remember those off the top of my head right now. We can check real quick, and there might be a way to do this. I want to say that they're similar. So what is this over here? No, not derivatives, just the identities. Cosh squared plus sin squared is cosh 2x. Yeah. Oh yeah. So cosh squared minus sin squared is 1. That's the main Pythagorean identity for the hyperbolic trig functions. No, those aren't there. No, this sucks. Let's do a regular search. But no, I would not advise trying to do this with any sort of hyperbolic substitution. The regular trig sub is the nicer way to do it. There is going to be a path for some of these, but they're going to be a little bit weird, like weirder than regular trig subs. I wouldn't do that. Identities. Yeah, there's no like super nice hyperbolic identities. They don't even list them here. There are things that correspond to the Pythagorean identity for the hyperbolic trig functions, but they're not very nice. So this is the path. This is the normal way and probably the best way to attack this. From here, we use what we know about secant cubed. So I could say, okay, I know the integral of secant cubed is 1/2 secant tangent plus natural log secant plus tangent. I know the integral of secant itself. That's the natural log of secant plus tangent. So from here, I say, okay, this is 25 times 1/2 bracket secant theta tangent theta plus natural log secant theta plus tangent theta. And I'll leave off my plus c till the end. So 25 times, here's the integral of secant cubed, minus 25 times the integral of secant, which is natural log of secant theta plus tangent theta on its own. And there's my plus c time. And now finally we can combine like terms. So this is going to be 25 halves secant theta tangent theta plus 25 halves natural log secant theta plus tangent theta minus 25 natural log secant theta plus tangent theta plus c, and these two can be combined. 25 over 2 minus 50 over 2 is negative 25 over 2. So I get 25 halves. So I keep doing that, secant theta, tangent theta, minus 25 halves, natural log, secant theta, plus tangent theta, plus a constant, and now we're ready to go back. So we use our triangle to go back. I'll scroll the triangle down here. Jesus. All right.
Would it be easier to write the adjacent side as just x squared plus 10x?
You can if you want to. It's a matter of taste. Does not matter. Either way is fine. In any case, my secant is going to be x plus 5 over 5. My tangent is going to be 5 over the square root term. So I'll have 25 halves times x plus 5 over 5 times my tangent, which is opposite over adjacent 5 over the square root of, I'll write it like this for now, but you could
Wait, I
write,
think your triangle might be messed up because unless
let's see.
I had opposite being the square root term and adjacent being the 5.
Well, so katoa, right? So secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant should be hypotenuse over adjacent. So the, oh shit, yeah, I wrote it correctly here. Yeah, I've got these switched. I'm sorry. I do, I have those switched. I'm so sorry. You're absolutely right. Yeah, I swapped these. So we'd have 25 halves. Secant is x plus 5 over 5. And then the tangent is going to be the root over 5. And then minus 25 halves natural log of now the sum of those things. So x plus 5 over 5 plus that root. All right, there it is. Yeah, you're right. These problems are ridiculous. Anytime you're completing the square, then trig sub, then a looping integral, it's hell. There's no nice way to say it. But if you can walk with Dante through all 9 circles of hell, then you won't have any problem sailing through purgatory, which is what I'm going to have you guys doing on the test. So think of this as the hard walk through hell to make the purgatory walk a little bit easier.
My issue is that these kinds of integrals are really hard to check. You know, if you make a mistake somewhere along the way, it's really hard not to just restart the problem entirely.
That's true. Yep. And this is one of those things that it's on purpose. That's very much on purpose. Later in the course, we will be working with an entire class, an entire category of problems that are challenging in that same way. Many, many steps, each very technical. One mistake in any one level fucks the whole thing. So we're trying to train a certain type of being careful here. We're trying to train like an extremely diligent care at every step with these sort of things. So that later when I'm asking you to do like, limit comparison tests for series, that sort of stuff, or when we're calculating massive tables of derivatives for power series, we can be 100% confident in every step. You're right, it's hard. It's hard at any step here. And if you make a small mistake anywhere, it can be really hard to find. If you make a small mistake somewhere and you charge through to the end, and then you compare your answer to the given answer and ask, well, where did I go wrong? It can be quite challenging. One thing that I know makes this less painful, if WebAssign says you're wrong, Wolfram Alpha is the right speed. Photomath, stay away from that. Bartleby, stay away from that. Those will let you think you know what you're doing when you don't know what you're doing. But if you come back here and you ask it to integrate the square root of x squared plus 10x dx, it'll give you the answer and it'll give you a little bit, but it won't give you too much.
And that's why I didn't use Wolfram here.
Okay, yeah, I would advise staying away from any of the really hot stuff, anything that gives you full step-by-step solutions. Definitely like the paid version of Wolfram, all of that are trouble. But you can compare these graphs to what you get. You can compare the answers they have here in the many forms to the answers you get. And it's not always a bad idea to do that. It seems like, so they're using the inverse sine hyperbolic to represent this piece. They don't have it in terms of the natural log here, but you could also graph what you have and compare the graphs. And I think this is a pretty common technique for asking. I'm not going to type it out, but if you graph what we got and then you look at their graphs here and see if they're the same, then you can be comfortable that, or confident that what you got is correct. But it's true, it's a very real challenge, and we are trying to train a particular kind of carefulness that is really hard to train. So while I recognize it is a form of suffering, I'll ask you to try and be strong through that. And then we can talk about these things in office hours, and that can help.
Thank you.
All right. Cody is next, and then we had a few folks hop in. So Cody, what can I do for you?
Originally, I was going to ask about study guide number, what was it?
I think I might have lost
Number
you.
7, but unfortunately I mistyped something, and that was the reason I was wrong on that question. And
Oh,
unfortunately, I've been mistyping a lot of stuff on this, and I am very concerned for the test.
well, so like I said, I'm going to be grading your written work. You know, don't worry too much about typing things correctly or incorrectly, because the exam is going to be graded based on the written work. The only thing you have to type for the test is your final answer. And if there's a small typo in that, I'll get it. You know, humans make typos. As long as there's not a huge difference between the typed answer and the written work, I'm not going to be suspicious or worried or anything. But were there any particular problems you wanted to see worked out?
No, although I would like to I don't remember how to choose for a trigonometric substitution the opposite and adjacent angle. I know how to choose the hypotenuse. That's easy enough, but it's just the way that the Pythagoras theorem is laid out. It could be either or for the opposite or adjacent, unless there's another rule that I'm completely forgetting about.
So really there's, like if I have something like this, or something like this, or something like this, these are the three situations in which we make a substitution like that. Here, x would be a times the sine of theta. Here, x would be a times the tangent of theta. I think he has to go outside, maybe. And here, x would be a times the secant of theta. I gotta let my dog out. I'll be right back. That's okay. It's fine. He ate his breakfast.
I can do it. You have to go. Just do what you're doing.
And then in each one of these, we kind of draw the triangle by following the trigonometry. So in this first case, sine theta is x over a, which I can think of as an opposite over a hypotenuse. So the missing side in each of these triangles actually depends on the substitution we're making. If I'm making a sine substitution, then I'll know the opposite and I'll know the hypotenuse. And then I have to solve for the missing side using the Pythagorean theorem and the fact that this is a right triangle. I choose to draw it as a right triangle. So the missing side length here, I solve for, I'll write it in here as b, why not? We know that b squared plus x squared would equal a squared. So where can I do that? B squared plus x squared equals a squared, which means b would have to be the square root of a squared minus x squared. For the tangent substitution one, I would know here that the tangent of theta is x over a. And I can think of that as an opposite over an adjacent, right? SOHCAHTOA. So here, I would draw my triangle like this, marking theta and the 90. So that opposite side would be x and the adjacent side here would be a. And then again, I got to solve for the missing side length. And I can do that using Pythagoras. I know this squared equals this squared plus this squared. So this guy will be the square root of a squared plus x squared. And then on the last one, is everything okay out there, baby?
Yeah, you know the shovel?
It's in the garage. I can get it. We need to clean up some hammy mess. Secant theta here will be x over a. And secant is the reciprocal of cosine. Cosine is the adjacent over the hypotenuse. So this will be the hypotenuse over the adjacent. So my hypotenuse is a, and my adjacent is, oh, I'm sorry, my hypotenuse is x, and my adjacent is a. And then if we want to, we could label this as b, but we can think about it. This squared plus this squared equals this squared. That means this has to be the square root of this squared minus this squared. So this is going to be the square root of x squared minus a squared. And a nice trick, you may notice that these square roots that we're solving for when we draw our triangles are always the thing that we were looking at when we substituted. 99% of the time, that's the case. 99% of the time, the thing that told you what substitution to make in your integral is going to be the missing side length of your triangle. So I don't know if does that really help what you were asking about? Is this kind of what you meant, or?
Yes, it does. X is always opposite unless it is the secant problem. Thank you. That confused me a bit.
Oh, yeah, that is true. Yeah, that's not something I've noticed in the past, but that's true. Yep. The thing that really saves me is just SOHCAHTOA, right? Sine is opposite over hypotenuse, tangent is opposite over adjacent, and secant, is the reciprocal of cosine. So the cosine is adjacent over hypotenuse, and then I flip it over. But yeah,
Yes, I remember now. You can change up that order. The problem is that you'll get cosecants, cotangents, and cosines that don't work well.
yeah, it's true. Those run into domain issues, and the sort of standard choices of domain restrictions for the trig functions correspond well with the definite integrals that we choose to do in this class. So I would try to keep it to sines, secants, and tangents, but you can get away with cosines, cosecants, and cotangents. We try to avoid them because they can cause domain problems here. All right.
I appreciate it, Professor.
Of course, happy to do it, Cody. I know Kaylee said she wanted to talk briefly after the office hour in private. So Tia, was there a problem you wanted to look at? I got just a little bit of time left here. Are you there, Tia? Hey,
Can you hear? Can you hear me?
yeah, you're good. I got you.
All right, awesome. I also want to talk to you privately. I emailed you for I emailed you about the concerns I have, but
Okay.
so yeah.
Yeah, I'm sorry. I've been so swamped with email, and I just moved house in the last couple of days, so I haven't checked email over the weekend yet. Let me do it this way then. I'll move you back to the waiting room because I think Kaylee got here a little bit earlier than you, and then after I finish with her, I'll pull you back in. Does that sound okay?
Yes.
Alrighty, so I'm gonna push you back to the waiting room, just hang out for a minute, and then I'll pull you back in after I finish with her. Kaylee, what's up?
Hey, how are you, Professor Foster? Can you close the door?
I'm good. Yeah, you're good. We're alone.
Oh no, I meant I was talking to my brother.
Oh, okay.
Yeah. So like this is gonna sound really weird, but I have not been like studying for the test at all because like I've been going through something. Well, that day that I told you I had an emergency, it all turned out better.
Good.
Like that day, like nothing happened. It was just a scare,
Okay. But you said something else has been going on? Oh, I think I lost you. I think you kind of slipped back into a mute.
Can you hear me?
Yeah, there you go.
Okay. Like, I don't want you to think I'm weird or crazy or anything. That's why I'm like.
It's not,
But-
don't worry.
So you know how I told you that I've been having like a lot of anxiety and stuff.
Mm-hmm.
So somebody told me that if you take like CBD oil, like it calms you down.
Oh yeah.
You sound unsure about that?
Yeah,
But,
I'm not sure myself about the actual efficacy of CBD oil. Did you have like a bad experience with it, or what happened?
yes, that's exactly what happened. Like, I had a horrible experience, and like I've been like so out of it. Like, I don't feel like myself, and like I'm honestly like really, really scared. Like, I feel like there's something wrong with me. You know what I mean? Like I don't know if like it messed me up or like.
I do know, so my wife used to work in that sort of field, and I do know that some of the CBD flower vendors and some of the CBD extract vendors do some shitty things where they put synthetic cannabinoids legal synthetic cannabinoids like JWH018 and other weird chemicals from China into their CBD herb to try and make it seem like it's more potent for people who actually want to smoke regular weed but are like looking for something under the counter. There are all sorts of weird CBD products out there that can give you some trouble.
Do you think I'm like,
So I would advise talking to a doctor. But then how long do you think you would need to be in a space where you could take the test?
I don't know, that's the thing, like, do you think like I know it's gonna sound stupid, but do you think I'm like gonna be stuck like this? Like this is like a permanent thing?
No, I don't think so. I think even the most unpleasant and unnatural of drug experiences wear off eventually. They just take some time.
Like I've been like literally like I can't sleep. Like I literally been sleeping with my mom. Like because I'm like so freaked out like that I don't feel like the same. Like those things that you're talking about that they put in them sometimes, are they like not weed? Are they worse than weed? Are they like
It depends. I don't know how much of this there actually is.
that's the thing I'm scared about.
So
I don't know. Like I don't know what to do, you know what I mean? Like
yeah, well, so I would treat this so that this is a thing, right? Investigation finds synthetic cannabinoids in this or that. I am not a doctor. I have no idea. My advice would be to talk to a doctor. But I can try to be helpful on this end as your professor. If you are medically unwell, then that's something that we could postpone the exam for a couple days for, at least while you were to talk to a doctor. But we would have to. So my rule for this is blanket rule for whatever reason. If we're going to need to do a makeup test, we got to schedule it for within 1 week of the original day of the test. And we need some sort of documentation. So my advice would be to talk to a doctor. Anything that happens and leaves you feeling like sick and not at all okay after a couple of days, no matter what it is, talk to a doctor about those sort of things. And then on our end, for practical purposes in the class, we could put the test off for a day or two until you were feeling better. That would be, we can be a little bit flexible there, but only finitely flexible. So how much time do you think you would need to be in a place where you could take the test?
that's the thing, like I don't know. Like I went to a chiropractor today and like I know it's gonna sound stupid. Like I don't know if you're gonna be like, oh that was a bad idea. Like
I don't judge.
I don't know if I should go to a medical doctor or a psychologist. That's the thing.
I would go to a medical doctor. If you want a medical doctor who specializes in psychology, those are psychiatrists. That's the difference between a psychologist and a psychiatrist. Psychiatrist is a psychologist who also has medical training. They tend to be a little bit expensive. I think depending on what your insurance is like, your cheaper options might be to go to somewhere like CareSpot or one of the Minute clinics in town, or even someone at Santa Fe might be able to help you. I don't know what kind of medical options we have directly at Santa Fe. If you're a student at UF, I know they have an infirmary there, but there are different options for student health services in town, and I would consider talking to some of them. They might be able to give you some sort of advice. I don't know how much of this they see. I have no idea what it is you experienced or where any of it came from. But general medical advice, they'll probably want to like take your blood pressure and make sure you're not poisoned or sick or something like that. And if all of those things are safe, presumably you just got some weird, unpleasant drugs, then you'll feel better. It might take a day or two. And I'm not.
But that's the thing.
Like,
That's why I'm
take this test right now. We can put it off a day or two, but it'll be.
That's why I'm scared though, because like I took this on Friday, and like I still feel weird. Like I feel dizzy whenever I walk. Like I don't know like if it's in my head or not, you know what I mean? Like I don't know if like I'm just like really fucking like traumatized because like I smoked weed like a while back like in high school and I did not like it. Like I was like I never want to get high again, like never again, right? And like they were like no, CBD like it doesn't get you high, like it can't get you high. You know what I mean?
Right.
So like my cousin, like she gave me 50 milligrams and it made me feel calmer. But then my brother went to this vape shop and he got some that were 35 milligrams and I ate the whole bag, like not in one day or anything, just like over time, and it did keep me calmer. But then like this freaking one, it was 125 milligrams. And like,
I
I just
wish I could give good advice. I wish I could say what's going on here, but for so many reasons, some of them legal reasons, some of them ethical reasons, some of them just me needing to stay like really hands off when it comes to students and drugs and things. I cannot even begin to say what you should do or what happened or anything like that. But I do think good advice here would be to talk to a doctor, talk to a chill doctor, talk to a doctor that deals with students somewhat often. I guarantee you.
the thing is, I'm not in Gainesville. Like I live in Ocala.
Yeah, there probably are some telemedicine options. I'm really not too sure. But that would be, if you're looking for like a jumping off place, maybe a counseling service at Santa Fe. They,
Like, I don't know, like
Probably
because
help.
I went to a chiropractor today, right? Because I tried calling like a psychologist place, and they told me like the earliest they could like put me in was the 18th of March, and
yeah,
I was like,
that's a challenge. It is. It's very hard to
yeah.
get seen quickly. But if
So
you
then,
call these people, this phone number you see on screen right now, if you call them and explain a
can I
little
see
bit
it?
what's going on, they should be able to give you some sort of advice, maybe even a referral, and they might be able to refer you to a psychiatrist who's local in Ocala. Like I said, I'm not going to put a hard date on this beyond saying we either need documentation saying like, Kaylee cannot take this test for 90 days or whatever from a doctor, or we need to schedule the makeup within a week. So for right now, what I'll do is I'll just put you on the makeup list for the test. For
Okay.
exam 1, and then I will wait for you to reach out to me, but we will need to have a conversation sometime within the next few days establishing the date of the test. And unless there is a very good reason to not do this, we will need to do the test within a week. So the absolute latest
Would be within a week.
right would be by the 15th. So I'm going to say makeup for exam 1, date TBD, and then I will wait for you to reach out to me and let me know when you want to. Like I said, it's going to be a different test. It won't be the same test that that the rest of the class takes, and it will it'll have to be done within a week unless for some reason a medical professional says we cannot do it within a week. But
I'm assuming.
drink lots of water, get lots of rest, and you'll be okay in a little bit.
Like, do you think? Like, have you heard of derealization or depersonalization?
Mm-hmm.
Do you think like that triggered this or something?
Everybody's mental chemistry is different, but I don't think most people are so sensitive to these sort of experiences that you're likely to jump into anything super traumatic like that. Things can be scary, but I think if you try to open yourself up to like feeling better instead of worrying about it, I know this can be like the last thing in the world that someone wants to hear, but if you try to get past the experience, that will help. It certainly won't hurt. So I would kind of slowly try to bring yourself back to doing things. Go outside, go for some walks, solve 1 or 2 homework problems, and see if you can't start pulling yourself together. I think it will be okay. But if you're really feeling not okay, then please talk to a doctor. That is genuinely the only advice I can give that I trust is 100% on point, is like, please talk to a doctor. Start at the counseling services here at Santa Fe, that phone number. Like I said, they will have people that you can talk to for psychiatric help. They can refer you to medical doctors if you need medical help. And that's really the place to start.
That's like, I'm so scared. Like, I messed up forever. You know what I mean?
I've known people who ate whole sheets of LSD and dripped vials of crazy drugs into their eyeballs and stuff when I was a teenager, and they all thought the same thing, but they came back. So whatever it is there
How long did it take?
snuck into
Long?
that CBD, I'm sure you'll come back eventually, Kaylee.
Eventually. What if it takes long? Like, I'm scared. You know what I mean? Like,
I don't think it'll take that long. Try to be brave and try to work on pulling yourself back. But I'm not a professional in any of these areas. Not a psychologist. Not a psychiatrist.
were they like overthinkers? Because I'm an overthinker. That's the thing. Like, I feel like that's what makes this even worse.
Some of them, in a sense, yeah. But I can't. Like I said, I don't know them especially well anymore, and I certainly don't know you well enough to compare personalities. I do have somebody else waiting in the waiting room right now though, Kaylee, so I have to move on and address those other things. But please call this number.
I will, like right now.
5508. Call them, talk to them. And if nothing else, they can communicate with me what's going on with you, and they can also help you find the sort of whatever it is you need, whether it's medical help or just reassurance or whatever. But I think you'll probably be okay. Stay strong.
Probably.
And continue communicating with me.
You said probably.
The probability of you not being okay is lower than the probability of a whale appearing behind me right now. And there's not going to be a whale behind me right now. You're going to be all right. But just contact them and then send me an email and we'll establish a date. Okay.
Okay. Thank you. I appreciate it.
It's all right.
Bye.
Hang in there. No stress.
Okay. I'll try to feel better. Bye.
Okay.
Bye.
It's annoying. I can't tell someone that they're not having a psychiatric episode. This is also the student that Katie asked me to be like very helpful with. I'm gonna write Katie a message. This is not hard. But I got one more I gotta pull in from
Did you
the.
tell her that Katie's told you to look after her? She's acting like a fucking psycho.
It'll be all right. Hey Tia, what's up? What can I do for you?
Hello.
How's it going?
For SA1, I have my accommodations for extended time, and I wanted to understand how would that like go as for submitting and how I would take the test.
So let me pop up my email and remind myself. I don't remember if did we finish your testing contract?
I remembered that I was going to take it at the testing center,
Okay.
and I submitted the application for the testing center. I just said that the submission said that I need a testing contract to be submitted by you.
Okay, so yeah, let me see here then. Here's the link for the testing contract. All right, let me get in here and we'll fill this out now and we'll make sure everything is as we want it to be. So I'm really offering, so at this point in time, do you know anything? So you do want to do the testing on campus, yeah. Do we want to do that just for test one, or do we want to have that be the thing that we establish for the whole term?
We think that was established for the whole term.
Okay, so we'll be testing on campus. Our online exams, measure exams will be in a Canvas. No property system will require exams to be hosted through Canvas. By DRC, please. All right. So the way the tests in your class work, I write them in Canvas, and there is HonorLock set up. Normally, I would be using HonorLock and Zoom with the other students, but since you're going to be doing this on person in a testing center, I will disable those things for you. So you'll be able to go straight in, but you're going to need to talk to the people at the testing center. I will send them the password, and once they're set up and whatever, they will give you the password to type in. So I'm going to go with this middle option here. And then on-campus paper quizzes or exams, we won't be doing any of those. Material permitted, scratch paper. And then, do you like to use a calculator, Tia?
Yes.
Okay. And for our class, the calculator, do you have a TI 30?
Yes.
Okay. I always forget if I'm TI 30. Is it like this, 30, then 2, then XS? Am I typing that right?
Yes.
Okay, cool. If the DRC, this, other stuff, right? Okay, good. If the DRC, all right, I already do that. That's no problem. Breaks, yeah, you can go out and use the bathroom and get water as you need to. Let's see. Due to possible extended accommodations, flexibility is the case to information agreements or stop time. Time in the and then standard time. So those are the standard times, and then they'll be adding your multiplier as appropriate. And then they want me to type these same things in here. 75. That's all we're doing. My phone number, they can call me. And that is it. All right. So your testing contract should be all set. I think right now things are a little bit complicated. So there's like the testing center, and then there's the big open lab, which is also now a testing center, and there's the DRC proctoring. So the people that we spoke to last time were in the big open lab in building N. Is that the group that you were talking to last time you talked to somebody about it, or were you talking to people at the DRC?
I was talking to people at the DRC.
All right, let's keep talking with people at the DRC. They will stay on top of all the organization and logistics stuff. And then I think that's going to be the smoothest way to handle all of this. So I think you're doing exactly what you should do. Keep talking to the DRC. Contract is sorted out. And then if they run into any trouble on the day of the test, they can call me and I'll fix it. Just make sure that you show up physically at the DRC like 15 minutes early so you can start logging in, because the default settings in Canvas are still going to have some time restrictions. Even though I'll be adding extra time for you, it is still possible that if you guys were to go way over, you could outclock the thing on Canvas, and I don't want that to happen. So make sure you show up on time for the DRC and we should be good to go.
All right. Thank you so much.
Of course. Yeah, happy to do it. Happy to do it. Is there anything else you wanted to talk about, or are you all good?
No, I'm good.
All right, cool. Have a good afternoon then to you.
You too.
Bye.
Bye.